kind of overlap from yesterday. Is that a little bit? How's this going to work? So we're going to do some question, or one question, based on this data. Now, if you take all the ages of Olympic College students, it's normally distributed like that, roughly. And the average age is 33. Now, it's not perfectly normal. They're actually, it's slightly skewed to the left, but you're allowed to get away with it. And the mean is 33 and the standard deviation is 8. So if I was using this, if I went 1, 2, 3 standard deviations either side, you'd get some data that makes sense and a little bit at the end it doesn't. So you add 8, you add 8, and then you add 8. And you take away 8, and you take away 8, and then you take away 8. In this particular distribution, it's not quite as accurate as it should be. Would you agree that you probably don't have many OC students who are 9? In fact, you probably don't have many OC students in that range. But, you know, we take that with a pinch of salt. We can still get good results from this data. And for instance, if I went and said to you, what percentage of OC students are 25 to 41 years old, and the answer would be 68%. Agreed? One standard deviation either side of the mean. Of course, I could answer questions like this. What proportion of students at OC are younger than 20, older than 41, or are between 17 and 19. Now, you can't use the empirical rule for these last 3 questions. What you can use, however, is mesh. So I'm going to now just do a few more questions on using SALT to answer more specific questions as we have here. And then we'll move on to chapter 3. Okay. So.
Okay, this is awkward.
I don't know what is awkward, Alice. Oh, she probably didn't mean to say that. Where are we going? Where are we going? There we go. Right. Are you looking at this thing here called chapter 3? Is that what you're saying? Okay. Now, that's going to be our next chapter. I'm just going to go to the SALT one. Here. Will I be able to do that? That's the question. No. Oh, here we go. I got it. Right. So are you seeing a normal distribution curve? Are we good? Normal distribution curve. Right. So the mean of OC was 33 and the standard deviation is 8, and you make sure that guy says normal distribution. So one of the questions I wanted to know is what proportion of students are younger than 20? So you hit left tail and you go here and you put in 20. And the proportion that you got is roughly 0.05. Now, if you want to know what proportion of OC students are older than 41, you do a right tail, you see olders to the right, and you put in 41. No, you don't put in 411, put in 41. And you get roughly, you get the answer 0.16. And if you want to know how many students are between 17 and 19, you do a between 17 and 19. And the answer we get is, at least in this case, not very accurate, it's 0.02. Are you comfortable about how you can use this to get more detailed answers rather than just using the empirical rule, right? It basically allows you to do any combination you could possibly want. And that's it. That's all I wanted to do there. So stop sharing. Are you comfortable about using salt then for those questions? Can we call that done? Good. Oh, almost forgot. Just a little detail, but you know, little details can catch you. If they say proportion, you write this. Sometimes they say percentage. Right, so just be careful when you're answering the question. Also, if they say 4 decimal places, make sure it is 4, because it can be a bit nitpicky if you round off to 3 or you don't round off at all. Yeah. We are finished. We're doing a new chapter. And today is going to be pretty much notes. So, patterns and scatter plots. What does that look like? Well, let's show you what a scatter plot is. It's when you collect data and it's paired together. Like, so it's not just a single number for each person, it's a pair of data. So you might, for instance, collect data on the age of someone and on their height. And you do it for, I don't know, 500 people. Now, we're talking ages of people, let's say, starting at babies and finishing at 15. So it's not everyone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that can be 13, 14, there's 15. There's 5, there's 10, and so on. Right. Now, what a scatter plot, oh, and height would be obviously in inches, so goes like that. And you found a 3-year-old kid and it was that height, and you found another 3-year-old kid and it was a bit taller, and you found a 5-year-old kid, and so on and so forth. Would it seem reasonable that you would probably expect data to look something like that? Right, older kids are taller and younger kids much smaller, right? And this is called the scatter plot. And when what we're going to do in chapter 3 is we're going to analyze how you can suck out information and describe these types of relationships that you get in scatter plots. So a lot of what we're going to do today is a vocabulary, how we describe things and what their names are. So we describe scatter plots by their shape, by their strength, and unusual points, which I'm going to give a new name to. So let's look at what shapes scatter plots tend to be. So I won't put any labels on these. When you get a scatter plot similar to the one we've just done here, and it looks like this, we say that its shape is linear. Does that make sense? Linear is just another word for straight, right? A linear. You ever heard of, linear functions? Isn't that straight line functions? It's linear. Sometimes would you agree that data has a curve to it? And I like to call it curved. I don't like that name, but I'm telling you because you'll see it. They call that data curvilinear. Can you imagine roughly this data is that line? And can you see the curve roughly in that one, right? Just to imagine it. Now, there are many other shapes you could have, but the ones that we're kind of most interested in are actually the linear ones because we can do a lot with those. Not really, apart from identifying them, we don't really pay much attention to them. So far, so good. And you might describe, if you get any other data set. Oh, well, here's one. I guess I can do this one because it can happen. This is just random. Can you imagine that you collected data and there's just no pattern at all, right? It's a bit like me getting your age and plotting it against the last 2 digits of your social security number. Would you agree there is no connection between your age and your social security number, right? Or your age and the last 2 digits of your cell phone number or something, right? That's the kind of shape you get. Random is a waste of time. If you find 2 things and the connection is that they're random, you really can't do much. Would you agree you can't use it to make predictions or tell anything? So we don't like random. Now, strength is our next fellow. So we talk about the strength of this relationship, right? The scatter plot. And it's kind of sliding scale. So you would have weak, moderate, and strong. You could call something moderately weak, or you could call it moderately strong. Let's look at some linear data. If the linear data wasn't a perfect straight line, but would you agree that all the points are very close to each other? That I would describe as strong. Right? That's a strong association. If it still looked linear, would you agree it's still got a kind of linear shape to it, but not a very good one? That I would describe as weak. And right in the middle, a moderate would be worse than that, but better than this. And there's a kind of judgment call sometimes. So I'll try my best to do that. I'll put my little spine thing first. There. Is that roughly sort of a not as good as that, but better than this? That would be an example of moderate. What's she doing? I don't like it. Chloe! I'm putting you in your cage, young lady. Chloe! Sorry about this, guys. She's under where my cables are, and I do not like her near electric things. Chloe, come here. You come out of there. Come on. Let's go. Come on, girl. Oh, she knows she's in trouble now. Come here. Come on. There you go. This is a little, yeah, kissing me is not going to save you. Come on. And you go here. Yeah. I'm just worried that she'll chew on some cable and, you know, hurt herself. So I put her in a little house. She'll cry for a minute and then she'll be fine. Okay, strong, moderate, weak, right? We good on that? Now, you can combine those two things when you're describing, there she goes, when you're describing a scatter plot. And put in unusual points. So here is some data. Would you agree it's curvilinear? Now, there is a kind of judgment call next. Would you call that strong, moderate, or weak? Kind of hard. Yeah. I think someone tried to say it, but I either cut them off or it disappeared. What would you
say? Moderate.
Yeah, okay. I'm not arguing over it, it's hard to tell. Moderate, or you could say moderately strong if you were feeling a little bit generous on the strong side, and couldn't you say moderately weak? No, it's a pretty vague description, right? It's not a scientific, you know, it has to be one and not the other. So that would be curvilinear. And I'm going to put in moderate, not because I'm right, I just want to, right? It's just what my feeling is, and if you don't agree with that, you could put moderately strong. Right? Now, unusual points. Unusual points are kind of sort of like outliers, but they're not necessarily outliers in the usual sense, where they're at the extreme ends. You know, an outlier is something that's really big and different from the rest of the data, or really small. An outlier in this world could be that guy there, could be that guy there, and could be that guy there. Can you see what makes them an outlier is that they're not part of the general data pattern? Right? Now, that number there is definitely not a numerical outlier. Isn't it right in the middle of the X's and roughly in the middle of the Y's? Right? It's not an extreme value. It's not like, oh, you know, 4,000, 5,000. It's not way out there. Unusual values, right? And these guys that are unusual values are still called outliers. I wish they had a different name for them, but that's what they're called, right? And that's why I called them unusual points at the start. I want to get you into the idea that when you do scatter plots, outliers can be anywhere, can't they? They just need to be different from the rest of the data. I'm a kind of visual person, so when I see this guy, I build sausages. There's my sausage. Do you see the 3 points we're talking about are not in the sausage? That's kind of how you decide, is it an outlier? So if I go back to, remember our first one, this one here, would you agree there are no outliers, unusual points in this data set? And if I was talking about my sausage, it would be that. In fact, one of the ways to decide on strength is, if you've got a dead skinny sausage, won't you be strong? If you get a kind of middle-sized sausage, you're moderate. And if you have a big fat sausage, aren't you weak? That's kind of how I visualize it. So if I go back to these fellas, can you see the sausage? Pretty skinny? That's strong. Would you agree it's a really big fat sausage? Weak. And it's kind of between these two extremes is what moderate looks like. Are we comfortable with shape, strength, and essentially what are called outliers, unusual points? Feel comfortable with that? So let's add. Fourth one. Positive or negative or no association. So a scatter plot can have positive association, negative association, or no association. Let's see what that looks like. Here is some linear data. This has positive association. What that means is, if you call this X and you call this Y, as X gets bigger, doesn't Y go bigger? In other words, it's going uphill. And we call that positive association. Now, can you imagine you have linear data, right? Going downhill. And that would be called, we would say that this had negative association. And then if you had, well, maybe a curvilinear shape that looked like a big fat U, that has no association. There's lots of no's. This is one example of it. The reason why this has no association, would you agree it's not always increasing or it's not always decreasing? It's kind of doing a bit of both. But you could have in no association, which is more common. Couldn't you have the big circle of nothingness? The random guys. In fact, won't random guys always have no association just because of their nature? Now, you can have positive association with curvilinear data. Would you agree that that guy is going uphill? So just travel from left to right, and is the pattern I'm going uphill? Positive association. Can curvilinear data be negative? Of course it can. Are we comfortable now about positive and negative association and what we mean by that? Right. Positive association is when things are going uphill. Negative association means things are going downhill, right? As X increases, Y gets smaller. No association means that there's nothing going on or nothing clear going on. Would you agree that goes down and up, so it counts as no association? So far, so good? Right. I'm going to write down a description of a scatter plot, and then we'll see if just through the description, we could draw it. This has a strong curvilinear positive association with no outliers. So if I was going to sketch this, it's strong and it's curvilinear. Positive, yep. No outliers, yep. Do you see from that written description, I could draw a reasonably good approximation of what the scatter plot looks like. So it allows you to describe scatter plots to other people, how you describe what's going on, what you see there. Now, if I put a dot here, wouldn't I say it had one outlier at 50,40? I'd have to tell you the coordinates so you knew where to put it. But if I could give you an outlier as an unusual point. Any questions so far? Say a lot of notes today. And most of it seems kind of common sense, just names that you give to things that you probably want to give names to, right? So let's see if we can name some scatter plots. So I'm going to do 3 scatter plots. Takes forever to draw these damn things, but that's fine. Okay, I'll call this guy A. I guess I'll call this one B. We'll call this one C. Okay, using all the terms that we have introduced today, let's see how many of them we can apply to scatter plot A. In any order you like, tell me one of the terms that you would use to describe A.
Negative.
Okay. Could someone else come up with another part of that? Negative
Linear.
is good. Agreed.
Linear.
Agreed. There is some more we can do.
Moderate.
Yeah, moderate works for me. I think this one's probably the hardest one for everybody to agree on. Would you agree? Some of you are saying that is strong, some are saying it is moderate. If you're really not sure, can't you stick the word halfway between them? Moderately strong, if that makes you feel better. And there is one more term that you could use for A.
Outlier.
Yeah, as one outlier. Typically, if it has an outlier, you can't really do it in my diagram, but can we pretend that that was at coordinates 10, 15, just for argument's sake? You would tell people, yes, there's one outlier, and you'd also have to tell them the coordinates of where to find it. Okay, on to B then. How would you describe B?
Linear.
Okay, that funny word, curvilinear. I can't even spell it. Curvilinear. Probably wasted that spelling. Curvilinear. I'll take that. Got some more.
Positive.
Agreed. Would you agree it's going uphill? Two more things you can do with this one.
Outliers.
Yeah, it's got 2 of them. and we tell people where they are. And one more thing. What's the strength of this?
I'd say moderate again.
I'd probably go moderate. Agreed. Right, last one. This fella.
Positive.
Agreed.
Strong.
Yes, I would agree. Two more.
Linear.
And one more.
One outlier.
And let's say that's at 100, 200, just for argument's sake. This outlier here is a little bit more interesting than the usual outliers that are just all over the place. Isn't this outlier in the same direction as the rest of the data? And most outliers, aren't they just stuck somewhere like, that must be a mistake, what's that doing over there, that kind of thing. But some outliers follow the data pattern, but what makes them an outlier isn't it that big gap there? Right. Isn't this point separated from the main data? That's all you need to be an outlier, right? You can be separated from the data up here, you can be separated down here, you can even be separated in the same straight line direction as the rest of the data, but you are separated, right? Now, if I took that guy and let's pretend that we had a few more points, is it still an outlier? Yeah, probably. Is it an outlier now?
Not really, no.
No. Didn't we have the same problem when we had normal data, right? Just normal single data, that there's a kind of gray area eventually where, yeah, it is or no, it's not. You know, you can do that with the other ones. If I put a point there, would you agree it's an outlier? Right, that's an outlier. If I moved it a bit closer, I think most of it would say still an outlier. When I move it to about here, would you agree it's now probably not an outlier? But isn't there somewhere between here and here? Isn't there a grey area where, yeah, it looks like it's not part of the data, but it's close enough maybe to be okay? And that means you're going to have to do judgment calls, right? So you look at data and Mark might say it one way and Autumn, she might disagree about the outliers. I don't think anybody disagrees about positive and negative. Would you agree it's kind of obvious something's increasing, right? Or something's decreasing. So that doesn't tend to cause any problems. Would you agree there's a bit of a judgment call about moderate, strong, and weak, right? Occasionally, it doesn't nicely fit into any of those three categories. So you might want to call it moderately strong. Now, that doesn't mean you're wrong if you said it was strong, or that you're wrong if you said it was moderate. Isn't that just your impression of what moderate and strong looks like might be slightly different from someone else's? I think that went actually pretty good. From the feedback I've got, are you comfortable about what scatter plots look like then? And all the different ways in which we would simply describe them. So I wasn't planning to do that, but that's fine. Let's look at some data where, there we go, where there is two pieces of information being put together. And here we go. For each of the following pairs of variables, is it likely to be positive, negative, or no association, right? So you don't have a graph to look at, which makes life easy. You just have a story connecting two variables. So the amount of alcohol that someone consumes and the performance on a test of coordination. And this is where a high score represents good coordination. So along the x-axis, 1 pint of beer, 2 pint of beer, 3 pint of beer, 10 pint of beer, and vertically upwards, what score they got in coordination, right? What would that look like? Positive, negative, or no association?
Negative.
Would you agree the more you drink, the worse you get at coordination? That's essentially what that is saying. Now, if the first thing gets bigger and the second thing gets bigger, that's what positive association looks like. When the first thing gets bigger and the second thing gets smaller, as it does in this story, that's what negative association looks like. If the first thing gets bigger and who knows what the second thing is going to do because it's got nothing to do with it, that's what no association would be like. So here's a no association one. You got the ages of people and you got the last 2 digits of their telephone number. Would you agree that there is no connection between those 2 things? That would be a no association. Now, the height and the grade point average for college students. So along the x-axis, they're 62 inches, they're 63, they're 64. And on the y-axis, their GPA is 2.0, 2.5, 3, and so on. What would that association be? Positive, negative, or none?
None.
Agreed. Tell us why not, Tanya. What made you think that?
Because height and grade point average don't have anything to do with each other.
Isn't that a good way of phrasing that question? I like the way she phrased it. They have nothing to do with each other. Isn't that going to give you no association? Wouldn't it be a miracle? Hey, the taller you got, the better your GPA is. See, if that was true, wouldn't people be going to hospital to get a height increase operation so they could be cleverer? You know, break your bones, stick in a metal rod at 5 feet, and you come out 8 feet tall, you'll be a genius. I mean, it's so stupid, isn't it? But, you know, that's what it is. Okay. How about this one? The weight of your car, right? So my car weighs 2,000 pounds or whatever, and the miles per gallon that I get.
Probably a
Negative.
negative association.
I think so. Would you? I think someone's child is doing music right now. Oh,
Yeah, that'd be my sister.
God, oh, poor soul. So you have to listen to me and her play music at the same time.
Yeah, well, the worst part is that she's just starting out, so like her intonation is pretty bad. And so sometimes it's really hard for me to concentrate because one of her is just so flat.
It sounds to me, if I can be cruel, because she probably can't hear me, that she's strangling a cat right now, but that's just my impression of what the sound sounds like. Okay, I've put it on mute so we can continue. If you want to say something, you'll have to hit spacebar. So we're talking about this car weight. I think I would agree with you that a heavier car typically doesn't get as many miles per gallon. I don't think it's a very strong association, because couldn't you have a big heavy car but a really efficient engine and you might get more miles, and a really light car with a really bad engine that's not efficient, right? But I think in general that would be a truism. That would make sense to me. I like these questions. They're nice and quick and you can do on your homework very easily. So same thing again. For each of the following pairs of variables, is it positive, negative, or no association? And they actually give you a reasoning behind it. So we're just doing the answer. You're going to have to choose what's a good reason yourself, because it might say positive in 2 places, and that's fine if it does. So the miles of running per week. Miles of running per week. Okay, how much you train, I guess, right? I run 50 miles a week. I run 10 miles a week. I run 200 miles a week. And the time in a 5-kilometer run. I think there's an association there.
Negative association, because one of the variables is going down and the other's going up.
Right. I'm making the assumption that if you train really hard, right, you run lots and lots of miles, won't you probably have a faster speed when you take the 5-kilometer run? Right. So more miles I run, quicker time, which I guess is training. Isn't that basically what people who do running do? They train, right? They do whatever it is they do lots of time. like your sister, will get really good at the violin because she's going to spend lots of time. Your forearm length and your foot length. Right, it's forearm, distance from my elbow to my wrist, right? My forearm. And how big my feet are. I've got an answer. I don't know if it's right. I've got my own answer. What's your answer?
Positive.
Okay, bigger forearms, bigger feet. Okay, that's not mine, but I'm not saying you're wrong. Any other answer?
I say no association.
I'm thinking there might be none. The human body has so many variations. Aren't there people who have very small feet and big long arms and big feet and tiny arms and everything in between? That's what I'm thinking. You'll find out what the book thinks when you put your answers. Now, since there's 5 of them, aren't you going to get the right answer eventually? So if it doesn't happen to be yours, I don't think you should say that Mark's wrong or that I was right. Isn't there a kind of judgment call in that, what you believe to be true? Because we're not medical experts. We don't know, thousands of people's forearm lengths and feet lengths to make an intelligent assumption on that. Now, C, for United States, the proportion of adults who receive a flu shot and the proportion of adults who get flu in that same year. So over the last 20 years, 1 year, 50% got the flu shot and 20% of them got the flu, that kind of details. So what do you think would be true in that particular story? The higher the percentage of people who get flu vaccinations, what would you think would happen to the percentage of people who actually got flu that year?
It would be a negative association.
I think there should be a negative, especially if the vaccine was one of the ones that worked. Are we all close to, or most of us close to, the fact that COVID is just going to be the flu from now on? That you'll get your flu vaccination or not, and you'll get your COVID vaccination or not, and next year, some of us will catch the flu and some of us will catch COVID. That's kind of what my lifestyle is thinking. And if they try and tell me that for the rest of my life, which is not that long, because I'm getting old, that I'm going to have to spend the rest of my life teaching from my office and wearing a mask everywhere and generally interfering with my life, then they've got another thing coming. I'm a great believer in people should eventually intelligently make guesses about what they should do with their life. And yeah, I understand that we have to be careful because old people and people who are in certain medical conditions, we have to be careful of. But those are the exact accent, close down the country and go bankrupt, in my humble opinion. Oh. Okay, here is some data. Good grief, this will have to be our last question. Having so much fun. I'll be honest with you right now. I disagree with quite a few of the questions here because there is such a subjective thing. I look at that and I say one thing and then I find out that the answer is slightly different. So you're going to have the same experience. So just live with that, right? Because it's a judgment call. Looking at that data, what do you see? Linear or curvilinear? That's the only choices I'm giving you because it is one of those two.
Linear.
Right. Do some of you see curvilinear?
I do.
I see curvilinear. The right answer is linear. You see what I'm talking about? Your brain is hardwired to see patterns. And that's great because it allows us to see things that the animal kingdom don't, right? We notice patterns and things. Unfortunately, because we are hardwired, some of us see patterns different than others. Can you look at a cloud and see a face? And other people look at it and say, what are you saying? There's no face there, right? That's just your imagination filling in gaps, right? So live with that, right? There's no calculation we can do, you know, like the 3 standard deviation deal, right? It's bigger than 3, it's an outlier. Stop arguing, it's an outlier, right? And so they're calling that linear, and I can live with linear because I know some of you saw linear, didn't you? So you know it's fine. Moderate, strong, or weak?
Moderately weak.
Yeah, I'd go moderate to weak. I don't think they give you that choice. So you're going to pick moderate and then it's wrong, so you'll pick weak. Or you'll pick weak and it's wrong, so you pick moderate. But you get 5 shots when you eventually get what they want. Is there any outliers? This I can agree on. You see,
Yes.
okay, where is your outlier? Because I thought we could agree on it and now we don't. So Tanya can see one that I don't notice. That doesn't mean she's wrong. It just means I haven't noticed it.
Maybe that 85 and 475.
85, 475. With this little gap there, is it because there's a little gap there?
Yes.
Yeah, and there's a kind of little gap here as well, isn't there?
Yeah.
That guy isn't an outlier in my book, and that guy's not an outlier. To be an outlier, you have to, in my mind, and I'm pretty much sure that WebAssign agrees, it has to be quite noticeable. So if you can see my mouse pointer, do you see where it is right now? My mouse pointer? If I had the dot up there, would we all agree that's an outlier? It's miles away. Now, this picture kind of stops, but see if I had a dot where my mouse pointer is now, I would call that an outlier. Right, let's do the one that's up here. It's an outlier. As I move towards the data, isn't there going to be some place around about here where you're going to say, nope, it's just a little bit out, but it's not an outlier? For instance, not an outlier, agreed? Is an outlier. Somewhere between those two, aren't you going to, Mark's going to say, at that point there, it's the last time it's an outlier. Anything else, it doesn't count. But Mark's might be there, and Tanya's might be there. You see, there's a judgment call. Don't mean you're wrong. It is what it is. And here is some stuff to do with it. And say your last name for attendance.